Good morning, Eli. How are you this morning?
Good.
Good. Did you have a good weekend?
Yes, ma'am.
Hold on. I'm trying to get rid
How
of
about you?
It was a very busy weekend. I was at JTF, the Junior Theater Festival, with the theater kids this weekend, and see, I think I got 4 hours of sleep on Friday and 5 hours of sleep on Saturday, and we were there for almost 18 hours. So I don't even remember yesterday hardly because I was so tired. I was like a zombie. Old ladies aren't cut out for that stuff. Whew. But it was fun. The kids did great performing their rendition of Mary Poppins, so that was fun. What'd you do this weekend?
I went bowling. That's about it.
Oh, really? Oh, fun. I haven't been bowling in, probably 2 or 3 years. That's fun. I love that. That's awesome. Did you go with your church or your family or friends?
Friends and family.
Cool. Cool. I wish I would have gotten more sleep in this weekend, but I guess that's this upcoming weekend. Maybe, hopefully. All right. Do you have any questions over like the classwork? Any of those that we did on Friday? It's been a minute, hadn't it? You have any questions over any of these? Or did you get through all of those on Friday? Do you remember? Did you get through these? Or do you just want to start with the classwork of today? Or do you have other questions?
Can you do 7, 11, and 12, please?
From the classwork on Friday?
Yes, ma'am.
Oh, absolutely I can. 7, 11, and 12. Okay. Now, these are the ones, where you have to multiply it by something first in order to find, to make the coefficients where they are common. You're kind of forcing them to be common. So what you want to do is look for things that are multiples of one another first and see if there's something, can I multiply just one of them by something in order to get that to match? And with this one, we know that 8 is a multiple of 4. So
wait, I have a question. Which worksheet's this?
Classwork from Friday.
Are we going to do the today's work?
Yes.
Okay.
But we're going to go over this first. I've started with any questions over the classwork on Friday, and then I'm moving to today's work. So this one, if you see where there's coefficients that are multiples of each other and you can get away with just multiplying one of the equations, you want to start there. So we know that 8 is a multiple of 4. So if we just multiply that top one, the whole equation by 2, we should be able to get matching coefficients, which is the goal. So we'll multiply that whole top one by 2. I'm getting in the habit of writing that dot. So 2 times 3x is 6x, and 2 times 4y is 8y, and 2 times 6 is 12. And now I'll rewrite that second equation underneath it, and we'll see that the y's now have matching coefficients. And then we look at the preceding sign, and they also are matching. So you want to, like signs, you're going to subtract. So 6x minus 7x is going to give me a negative x. And then 8y minus 8y cancels, which was our goal. And then 12 minus 10 is 2. And now we want to divide both sides by -1. And we have x equals -2. Then we plug that -2 back in to one of the two equations. I'm just going to pick the top one. 3 times -2 plus, you're substituting, really is what you're doing. We switch back to substitution. So -6 plus 4y equals 6. Add 6. I've told the answer. I do that. 4y equals 12. And then divide both sides by 4. And you get y equals 3. So the solution to this equation, and I do want to make sure y'all get in the habit of writing the solution once you've gotten both. The solution to this equation is -2, 3. So if I were to graph these two lines on a coordinate plane, they would intersect at the point -2, 3. So I believe you said 7, 9, and 11. Is that correct?
Yes, ma'am.
Okay. So number 9, not quite so easy. Neither one of those really are multiples of each other, like direct multiples of each other. The 5 and the 7 are not multiples of each other, and the 9 and the 10 are not multiples of each other. So really what you want to do is find the least common multiple of both of the numbers. So the least common multiple, and I would pick the smaller numbers most of the time. There would be, occasions when you might want to go with the bigger numbers if you can find a multiple that's small. But in this case, the first multiple that you would have for 9 and 10 is going to be 90. So that's kind of a relatively large number, and you're going to be multiplying everything either by 9 or 10. So I would pick 5 and 7, which means I'm going to have to multiply the top one by 7 and that bottom one by 5. I have to multiply everything, okay? Least common multiple is what we're doing. But 7 times 5 is 35x. And 7 times 9y is 63y equals -10. Oops, my bad. Got to multiply it by 7 also. So it's going to be -70. And then 5 times 7x is 35x. And 5 times 10y is 50y. And 5 times -1 is -5. So now we have matching coefficients on the x, and the sign preceding them is the same. So we're going to have to subtract. So 35x minus 35x is 0. That was our goal. Those two cancel each other out. And then 63 minus 50 is 13y. Oops. Did I do that right? Yeah. And then -70 minus a -5. That's going to make that a +5. So this is going to make this a -65. Because if I do a -5, that's going to be 65. So divide both sides by 13. And then y equals -5. Now I'm going to substitute back in that -5 into one of the two equations. I'm just going to go with the top equation. So 5x plus 9 times -5 equals -10. 5x plus -45 equals -10. Add 45 to both sides. And I'm going to move it. And then I have 5x equals 35. Divide both sides by 5. And x equals 7. So the place at which these two lines will intersect, or the solution to the equation, is 7, -5. Number 11. On this one, I have to get both. One of them is not in standard form. So I have to get it into standard form, and that's that bottom one. So what I would have to do there is add 6y to both sides. So now I have 3x plus 6y equals 12. So I'll rewrite both equations over here. Now what I want to do is, once again, I don't see any direct multiples of one another. But what I do know is that I could multiply the top one by 3 and the bottom one by 2 to get them to match for the x's. And then the other thing that I can do is I could also multiply. Well, that's going to do the same exact thing, actually, because I was thinking about the 12, trying to match the 4y and the 6y and get it to be 12. So what we'll do is multiply the top one by 3 and the bottom one by 2. And so 3 times 2x is 6x, and 3 times 4 is 4y is 12y equals 3 times 6 is 18. And 2 times 3x is 6x, and 2 times 6y is 12y, and 2 times 12 is 24. Uh-oh. Let's see, we have matching coefficients on both the the x's and the y's. We have 6's and 12's. So that's going to be 0 equals -6 if I subtract. And that is not a true statement. So this would be no solution. These are parallel lines.
Miss Sparks, did you already do number 10?
On the classwork from Friday?
Yes,
no,
on the sheet that you're doing right now.
No, ma'am.
Okay. Can you
want me to do? Uh-huh.
Thank you.
You're welcome. So you said number 10, right, love?
Yes, ma'am.
Okay. All right. Eli, does that clarify those 3 for you? Did you need me to do 12 too? I can't remember.
Yes, ma'am.
You do need me to do 12 also?
Yes, ma'am.
Okay. Do you care if I go back up and do 10 and then end with 12?
It doesn't matter. I'm
Okay.
fine with anything.
Okay. Thank you, sweetie. All right. On number 10, it also is not in standard form. The first equation isn't. So we have to get it in standard form. So on that one, what you would want to do is subtract 4y from both sides. So you get 2x minus 4y equals 18. And then underneath that, we'll rewrite that first equation just to kind of, actually, I don't think that's what I'm going to do. I think I'm going to swing over here and rewrite this newly written equation underneath this. 2x minus 4y equals 18. All right, so we don't have any matching coefficients, nor do we have direct multiples of one another. So what we want to do is take a look at these two equations, and the least common multiple is where we want to go with. And that's probably, I would look at that 6 and the 4 and realize that 12 is the least common multiple of that. Almost like getting the least common denominator. So I would multiply the top one by 2. And, or this one right here by 2. And this one by 3.
Which one did you multiply by 2?
This one. I'm going to change colors so that you can tell. Okay? Because 12 is a multiple of 6 and 12 is a multiple of 4. And it's pretty small that way. I'm not using really big numbers. Does that make sense?
Yes.
Okay, because here's that kind of broken down. 3 and 2, 2 and 2. And to find the least common multiple, you want to make sure that each factor is used. So that's used. This is used. And then that counts for this one, because there's 1, 2, and 4, and there's 1, 2, and 6. And then you got to multiply that second repeating 2 there. So 3 times 2 times 2 is 12. And that's how you get the least common multiple. Okay? Now, multiplying that top equation, or this equation right here, by 2. 2 times negative 5x is negative 10x. 2 times negative 6y is negative 12y. And 2 times 3 is 6. And 3 times 2x is 6x. And 3 times negative 4y is negative 12y. And 3 times 18 is 54, I believe. Trying to do that in my head real quick. Woo! All right. So I have matching coefficients, and checking out the preceding sign, I've got matching signs. So I'm going to subtract the top equation, or the bottom equation for the top equation. So I have negative 10x minus 6x. So that turns that to a minus minus. So that's going to be a negative 16x. And then the negative 12 minus a minus 12y, those cancel. And then 6 minus 54 is going to be a negative 48. Divide both sides by 16. Negative 16. And that's going to give me x equals 3. Now I'm going to plug that 3 back into, I'm just going to use that top equation. 2 times 3 equals 4y plus 18. 6 equals 4y plus 18. Subtract 18 from both sides. And that gives me negative 12 equals 4y. Divide both sides by 4. And y equals -3. So the solution to this equation is 3, -3. And now number 12. Once again, it's not in standard. Both are not in standard form. So we've got to make this second one into standard form. I'm going to subtract 7y from both sides to do that. That gives me -2x minus 7y equals 26. So now I'm going to rewrite my equations so that the terms are lined up underneath each other. And on this one, you could either use the 5 and the 7 or the 7 and the 2 because neither are direct multiples of each other. So I'm just going to take 2 and 7 since those are smaller numbers, which means I have to multiply the top one by 2 and that bottom one by 7. So 2 times 7x is 14x. 2 times 5y is 10y. And 2 times -13 is -26. 7 times -2 is -14x. 7 times -7y is -49y. And 2 times 26 is 52. So I have matching coefficients on the x, but the signs are different. So I'm going to add them to each other. And that's going to cancel these two out. And now I have a 10y plus a -49y. So that's going to give me a -39y. And then, oops, you know what I forgot to do? I forgot to multiply. That's 7 times the 26. Oh, sorry about that, guys. Can't forget that. 26 times 7. 182. So I'm going to add 182 and a -26, which really means that I'm going to find the difference and give the sign of the higher one. That gives me 156. And then I've got to divide both sides by -39. And -39 goes into 156. Oh, actually, yeah. Y equals -4. So I'm going to take that y equals -4, substitute it back in. I'm going to use the one with the smaller numbers. It's kind of -2x equals 7 times -4 plus 26. -2x equals -28 plus 26. So -2x equals -2. And divide both sides by -2. And x equals 1. So the solution to this equation is +1 -4. All right. Now, Is there any specific did everybody get that needed it? And are there any specific, did you get them, sweetie?
Yes, ma'am. Thank you.
Uh-huh. Are there any specific questions over today's work?
I'm confused on number 1 and number 11.
Number 1 and number 11. Okay, so we'll hit those for sure. Are there any other ones?
Can you start on the back?
Yes, I'm going to do number 1 since that was asked, and then I'll switch to the back. Okay. All right, and then I'll do that because I think obviously number 11 is probably on the back, right? Just asking. Okay. All right, so on this top one, we have a coefficient of 1 on the top one, so we could get away with just multiplying it by 5 to get matching coefficients. So we would have 5x minus 10y equals 60. And then that would match that 5x on the bottom there, and the coefficients would then match, and the signs preceding them would be the same. So we're going to subtract this bottom one from that top one. So 5x minus 5x, those eliminate, which was our goal. And then negative 10y minus 3y, that's going to give us negative 13y equals, and then minus 60 minus 44 is going to give us a positive 104. Then we're going to divide both sides by negative 13, which will then give us y equals negative 8. Then we'll substitute that negative 8 back into the equation. Negative 2 times negative 8 is a positive 16. Subtract 16 from both sides, and then you get x equals negative 4. So the solution to this system of equations is negative 4, negative 8. And then I know for sure that Mary Faith, you wanted me to do 11, but Eli asked if I would start on the back. Do you care if I do a few of those and then move to 11?
No, I don't mind.
Okay, thank you, sweetie. I appreciate y'all cooperating with one another. That's a blessing. All right, on number 7, let's see. No, obviously no matching coefficients. We're going to have to multiply first. That's the point of this particular assignment. And then we want to look at the least common multiple, not having to multiply by big numbers. So that's going to probably default to multiplying that top one by 5 and the bottom one by 2. So that's going to give us 10x minus 30y equals 60. And then 2 times negative 5x is a negative 10x. And then 2 times 15 is a positive 30y. And then 2 times negative 30 is negative 60. Oh my, look at that. Everything cancels. So that's going to be 0 equals 0. That's a true statement. So the answer to this is infinity. They are the same line. Number 8, on that one, best thing to do is multiply the top one by 3 and that bottom one by 2. And 3 times 5x is 15x. And 3 times 2y is 6y. And 3 times negative 3 is negative 9. And 2 times 3x is 6x. 2 times 3y is 6y. And 2 times 9 is 18. 15, let's see. The 6y's match. The sign preceding the 6y also matches. So we need to subtract that second equation from the first. 15x minus 6x gives us 9x. These cancel or eliminate. And then negative 9 minus 18 is negative 27. Divide both sides by 9. And x equals negative 3. Substitute that negative 3 back into the equation. That second one has smaller numbers, so that's the one I'm going to pick. Keep it simple where you can. Add 9 to both sides. We have 3y equals 18. Divide both sides by 3. And y equals 6. So the solution to this system of equations is negative 3, 6. On number 9, I'm going to multiply that top one by 4 and that bottom one by 3 in order to force my x's to be matching coefficients. So 4 times 3x is 12x. 4 times 2y is 8y. And 4 times negative 26 is 104. Should have known that. And then 3 times 4x is 12x. 3 times negative 5 is negative 15y. And 3 times negative 4 is negative 12. So our x's are matching coefficients. They have the same sign, so we're going to subtract. The x's eliminate. We have 8y minus 15y. So that's going to give me a positive 23y. And then we've got negative 104 minus a minus 12, which means we're going to, that would technically become a positive 12. So you have to find the difference and give the sign of the higher one. So that's going to be negative 92. Divide both sides by 23. And y equals negative 4. Substitute that negative 4 back in for y. 3x plus 2 times negative 4 equals negative 26. 3x minus 8 equals negative 26. Add 8 to both sides. And that's going to give me negative 18. Divide both sides by 3. And x equals negative 6. So the solution to this system of equations is negative 6, 4. Oh, negative 4. Do you all need me to do 10 and 12, or can I skip to number 11?
Can you do 10 and 12, please?
Yes. Okay, what do you think I'm going to multiply 10 and 12 by? Or 10 by the top and bottom equation? What would you pick?
4 and 3.
Yes, good job. 4 and 3. Multiply that top one by 4 and that bottom one by 3. So 4 times 4x is 16x. 4 times 3y is 12y. And 4 times -1 is -4. 3 times 5x is 15x. 3 times 4y is 12y. And 3 times 1 is 3. We look and we see that our 12y's are matching coefficients, and the signs preceding them are also matching. So we're going to subtract the two equations. 16x minus 15x is x. And -4 minus 3 is -7. Substitute -7 back into one of the two equations. I'm going to pick the top one. Once again, trying to find those smaller numbers, keeping it simple where I can. -28 plus 3y equals 7. Add 28 to both sides. 3y equals 'Did I do something wrong? Or I can't read my, I can't read my writing. That's a -1. Oh, I'm like, wait a minute. It helps if you can read your own writing, you know? So 27. I'm like, what number is that? So divide both sides by 3, and y equals 9. So the solution to this system of equations is -7, 9. All right. Number 11. They're not in standard form. The second one is not in standard form. So I need to swap it to standard form. And in order to do that, I'm going to add x to both sides. So I have x plus 2y equals 5. I'm going to rewrite that second equation down here so that they're lined up. My terms are all lined up underneath each other. And I note that my top equation, or my newly written top equation right here, has a coefficient of 1. So that means all I have to do is really multiply it by 2 to get a new equation where I have a top and a bottom equation, or a top and two coefficients that match. Whoa. Back to school.
Flip it to the other side. That's where I did the most work. It's like you have to do the elimination stuff, but then on the other side, you have to multiply both equations, and it's just... Here, I'll start. You have to multiply both equations to get the same number to eliminate.
Right.
I think I did it wrong on the first one. I went, oh.
On this one right here, that one you only had to multiply 1, thank God, right? Because this one, you could multiply just the top equation by 2. And then this second one, now you have coefficients that match, both the 2x and the 2x. And so the coefficients match. And then, since then you look at the sign that precedes it, they're an assumed, they're both positive. So I'm going to subtract 2x minus 2x. Those eliminate. And then 4y minus 3y is y. And then 10 minus 6 is 4. So now I'm going to substitute that back in. 2 times 4 equals 5 minus x. 8 equals 5 minus x. Subtract 5 from both sides. That gives me 3 equals negative x. Have to divide both sides by negative 1. And so x equals negative 3. So my solution to this system of equations is negative 3, 4. And number 12. The top one is not in standard form, so we have to get it in standard form. And we'll do that by subtracting 2y from both sides. So that gives us 3x minus 2y equals negative 7. I'm going to rewrite my other equation right underneath so I can see what I've got. And it looks like I'm going to have to multiply that top equation by 2 and the bottom equation by 3. And so then that's going to end up looking like 2 times 3x is 6x. 2 times negative 2y is negative 4y. 2 times negative 7 is negative 14.
Miss
3
Sparks,
times, yes.
when you're done with this one, could you go back up and do 7 and 8?
Yes.
All right, thank you.
You're welcome. 3 times negative 5. I appreciate asking questions. 3 times negative 5 is negative 15y. 3 times 10 is 30. So now our coefficients on our x's match. The sign preceding them are both positive, which means I have to subtract one equation from the other. The x's eliminate. Negative 4y minus a minus 15y. That makes that 15 positive. So that's going to be an 11y. And a negative 14 minus 30 is going to give me a negative 44. Divide both sides by 11. And y equals negative 4. Now I'm going to substitute back in that negative 4 into one of the two equations. Which one should I pick? I'll just pick the top one. 3x.
Can you scroll down a little bit? I can't see the bottom of it.
Does that help? Or no?
Yes. Yes,
Okay.
Thank you.
2 times negative 4 minus 7. So 3x equals negative 8 minus 7. 3x equals negative 15. Divide both sides by 3. And x equals negative 5. So the solution to this system of equations is negative 5, negative 4. All right. Jet, was that you that asked for 7 and 8? Who was it that asked?
Yes, ma'am. That was me.
Okay. All right. You want me to start over so you can see it done?
This is fine, actually, right here.
It is? Are you sure?
Yeah, I can see how you
I don't
do it.
mind
You can
walking
if you
through it.
want, but I can see how you did it.
Okay. Well, I don't mind walking through it if you want me to, sweetie.
Let's just do that then.
All right. I never mind that. I like it when y'all come and ask questions. It's what this is for. Let me get everything erased. Okay, on number 7. What you want to do is see if you can find the least common multiple. You always want to do that. And I don't see anything other than having to, multiply the top and the bottom by, I mean, if you use 6 and 15, you could, obviously it's going to end up in this particular one turning out to be the same thing. The least common multiple of 6 and 15 is actually 30. But the least common multiple of 2 and 5 is 10. So I would probably start there. Just because it seems in my head to be smaller, but you're going to find out it's really the same exact thing in this particular case. So you multiply the top one by 5, everything in it, and you multiply the bottom one by 2. Okay? Top one by 5, bottom one by 2. 5 times 2x is 10x. 5 times negative 6y is negative 30y. And 5 times 12 is 60. 2 times negative 5 is negative 10x. 2 times a positive 15 is a positive 30y. And 2 times negative 30 is negative 60. Well, all of our coefficients match, and conveniently, the signs preceding them are opposite, so I would technically add both of them. But it turns out to be 0 equals 0. That is a true statement. So that means there's an infinite number of solutions when it's a true statement. And it also means that these two lines are actually the same line. Okay?
Yep.
Does that help?
Yes, ma'am, that helps.
Cool. Okay, on number 8, you're going to have to multiply the top one by 3 and the bottom one by 2. In order to get your coefficients to match, because that's probably going to be the easiest way to do that particular one, with 2 and 3 being the smallest. Better than multiplying everything by 3, the top one by 3 and the bottom one by 5. All right, 3 times 5x is 15x, and 3 times 2y is 6y. And 3 times negative 3 is negative 9. 2 times 3x is 6x. 2 times 3y is 6y. And 2 times 9 is 18. Our y's now match, and the sign preceding them are the same, so you're going to subtract one equation from the other. 15x minus 6x is 9x. Negative 9 minus 18 is negative 27. Divide both sides by 9, and we get x equals negative 3. Take that negative 3 and substitute it back into one of the two equations. I try to pick the one with the smallest numbers, which to me in this case is going to be, just keep it simple where you can. It's going to be that second one. Substitute that x, that negative 3 back in for x. Negative 9 plus 3y equals 9. I have to add 9 to both sides. That gives me 3y equals 18. Divide both sides by 3. And that's y equals 6. So the solution to this system of equations is negative 3, 6.
All right, thank you.
No problem. Thank you for asking questions.
Yep.
Are there
I'm going to
any?
head out now.
Okay. All righty. Have a good day. All right. Are there any other questions?
No, ma'am. Thank you very much.
You're most welcome. Y'all have a blessed day.
You too.
Hey, Miss
Thank you.
Sparks, is number 4 no solution?
Number 4. Let me see. It is. It is no solution.
Thank you.
They're parallel lines. Good
Is
job.
Is there any chance you could do 2 and 3?
2 and 3? Yes.
Okay.
Okay.
Thank you.
On number two, you're going to multiply that second equation by 2.
Thank you, Miss Sparks. I gotta go.
Okay, sweetie, have a blessed day.
You too.
Thanks for coming to Math Lab. So it's going to be 8x plus 2y equals 30, or yes, 38. And this, I'm just going to rewrite that top one. So now my coefficients on my y's matches. They're both 2's, and they have opposite signs, so that means I'm going to add them. 7x plus 8x is 15x. And negative 2y and a positive 2y eliminate, cancel each other out. And 37 plus 38 is 75. Divide both sides by 15. And x equals 5. Substitute that 5 back in. I think I'm going to use the second equation. 4 times 5 plus y equals 19. 20 plus y equals 19.
Shouldn't you multiply everything by -2? Because it says -2y.
Where?
In the first equation, it says 7x.
I substituted it into the second equation.
Okay, that doesn't make much sense, but okay.
What doesn't make sense?
Why it's +2, not -2? When you multiply the second equation.
I multiplied the second equation by a +2.
Why not -2?
I mean, you could do that so that the coefficients are the same, like matching signs. You don't all they, if they have opposite signs, remember you can add them. Remember?
Yeah.
Is that your preference?
I don't know.
So you multiplied everything by a -2 on that bottom one.
I think that's what you should do, but I'm not sure.
You can do it either way.
Okay. It's just whatever number's next to the y in the first equation.
Well, you're trying to eliminate, and do you see where? Let's write this down here. Ignore this. If I have a -2y and a +2y, I add, right?
Yeah.
But if I have a -2y and a -2y, I subtract, correct?
Yep.
So either way is okay. Does that make sense now?
Yeah. Yeah.
Or no?
It does.
Are you sure?
I think so.
Okay. Do you prefer getting it where you're always adding? Is that what you're saying?
I'm not really sure.
Well, because I want to do it the way you're going to do it every time. So you would have multiplied that by a -2. Is that what you're saying? Because see, you can eliminate either way. It just, if you have matching signs, you add or you subtract. If you have unmatching signs, you add. But you can do it either way. Remember how, and when we were adding and subtracting, you looked at the coefficient to make sure that the numbers matched. And then you looked at the sign preceding it to determine whether you added or you subtracted. Does that make sense? You remember that?
Yeah, I would just multiply by -2, I think.
Okay, because you like to add all the time. You don't ever like to have to subtract. Is that correct?
Yeah.
Or you like to subtract all the time? I'm sorry, I said it backwards. Well, I can redo it that I can redo it that
No,
way.
you don't need to redo it. It's fine.
Well, I know, but I want to do it the way that you understand it best, because that's what Math Lab's about. And I love that you stopped me and asked the question. That's awesome, Grayson. So let's just do it that way, because I want to show it to you the way that you're most likely to do it. All right, honey? Okay, so you would multiply that by -2. So let's do it your way. You're going to ultimately get the same answer, but it's better to work it out the way you would do it. So then that would be -8x minus 2y equals -38. So because the coefficients are the same and the signs are the same, I'm going to subtract. Okay? So now I have a 7x minus a -8x, which is going to give me 15x. And then I've got a 37 minus a -38, which is going to be 75. Divide both sides by 15, and x equals 5. So now I'll plug that x back in. Does that make sense? Better sense to you?
Yeah. It's easier
Okay.
in my mind.
In your world. Okay, cool. That's fine. Subtract 20 from both sides. But do you see how you get the same thing? Isn't that cool? That everybody gets to kind of approach it a little differently and you still get the same answer. Okay, so 5, -1 is the solution to that one. All right. On number 3, 8 is a multiple of 2. So I'm just going to multiply that bottom one by 4. So I'm going to rewrite the first one. And then 4 times -2x is -8x. 4 times
Wait.
2.
Where'd you get 4?
Why? Huh?
Where'd you get 4 from?
I multiply 4 times 2 to get 8. 8 is a multiple of 2.
I know, but
Right?
how did you know to multiply the equation by 4 instead of some other number? Like, where did you get 4 from?
8 is a multiple of 2. What do I have to multiply 2 by to get 8?
Okay, that makes sense. That's what I've been trying to figure out.
Yeah, you're trying to eliminate one of the two equations. I mean, one of the two terms. And so sometimes you can multiply one of the equations by something and get them to eliminate. But sometimes you have to multiply both equations to get one of the terms to eliminate.
Okay, this one makes more sense now.
Okay. 4 times 8 is 32. So 72. And now my y's have matching coefficients. The sign that precedes them is the same. So I'm going to subtract everything. So I have a 3x minus a -8x. That's going to be 11x. My y's eliminate. -5 minus 72 is -77. Divide both sides by 11. And x equals -7. I'm going to substitute that -7 back into one of the two equations. -2 times -7 plus 2y equals 18. Negative 2 times negative 7 is a positive 14. Subtract 14 from both sides. 2y equals 4. And y equals 2. So the solution to this system of equations is negative 7, 2.
Thank you.
Uh-huh.
Can you keep it there for just a second?
I sure can. And like Eli asked me, that one is no solution. So. All right. Y'all have a blessed afternoon, okay?
Thank you so much.
You're most welcome. Take care. Bye-bye.